This was our topic, the measurements in astronomy, and just a review of yesterday's class. That's all. Don't worry. Yeah. Then the question was how we measure the distance of real astronomical thing. We cannot use any measuring tape, say direct thermometer or anything like that. What we only have is the light from the cosmos, and light is classified into many types of light, which are actually not visible to our human eye, like the gamma ray, X-ray, ultraviolet, etc. And only the visible light can be seen with the or visible or sensible for our human eye. So that you remember, I hope. Then we mentioned that not all of the light from the cosmos or from the space is actually reaching the Earth's surface. Only the visible light and radio is mostly coming to the surface of Earth. For other kind of lights, if you want to see the space in other kind of lights, we have to put telescope into space. Just a moment. I'm sorry. Just a moment. I will be back. Okay, so sorry for the interruption cost. So that is why we send a telescope into space so that we can observe the sky in different kind of lights, like the different telescope that you see in the upper row, like the space telescopes, like JWST, Hubble Space Telescope, Chandra, X-ray telescopes, etc. And there is not only lights, there are gravitational wave, cosmic rays, neutrinos are also being observed, but it's only a fraction, only a small part when compared with the real light. Okay. Now then we discussed about the cosmic distance ladder. That means if you want to measure the distance in the cosmos, we have to use different methods for different ranges. Okay, so the method that is used to measure the distance to Venus is not applicable to measure the distance to nearby star like Proxima Centauri or some other star like Betelgeuse. So for those stars, we have to employ another method like the parallax method. And that same parallax method won't be applied for the nearby galaxies. Okay, for nearby galaxies, parallax method is not that applicable. The better to use the Cepheid variables. And if you want to go beyond that, then we have to use what is called a supernovae. And beyond that, we will use the Hubble's law. So Hubble's law I haven't discussed because we will learn that in detail in the last session, because you have to learn the Hubble law first. Okay, so that is about the distance ladder. So for different range of distance to be measured, we need different methods for measurement. So that is why it is called a it is like a ladder. Each step has each different method. So it is called a ladder-like structure is there, which is called the cosmic distance ladder. Okay. Next, we discussed about the parallax. In that parallax, we observe the same object from two different perspectives or from two different places like this. And from those different observation, we can compare those picture like this. Here you can see like this, and from those pictures we can get the distance. Okay, using some equations and all, we can get the distance. So that is the summary of that parallax. And then we learned something called the flux and luminosity, where luminosity is the actual energy emitted by an object and flux is the energy that we received at Earth or wherever you are standing. So flux and luminosity are connected through distance, and if you know the flux and luminosity of an object, then we can easily calculate the distance to that object, which is generally called the flux and luminosity method. But the problem here is flux is so easy to calculate. Just place a telescope on Earth's surface and observe, we get the flux, but at the same time the problem is that we cannot get the luminosity. So there are some other objects for which we know the luminosity in some other way. So they are called the standard candles. One of the standard candle is the Cepheid variable. For Cepheid variable, it is actually a brightness changing light star, something like its brightness goes to a peak, then come down, then go to peak, then come down, something like that. So from its luminosity, or from its period, or how long it will take for the change, from that timing we can get the actual light emitted or the actual energy emitted from that, and using that we can find the distance. Similarly, the peak brightness of a type 1a supernova, not here, it is not any supernova. For type 1a supernova, that also can be used as a standard candle. So this is what we discussed in the last class. So these are some of the methods that we employ to find the distance to cosmos. Okay. Then let's go to the other thing, that is another branch of science. Especially this branch of science is used everywhere, in the sense that in physics, in chemistry, even in biology, or many different branches it is used, which is called the spectroscopy. So spectroscopy is something like it looks colorful in this way. You can see some rainbow of colors here. So this is on the left, what you're seeing is a prism, okay, and the right side, you hopefully know that this is a simply CD. What is the connection between them? So before going to the connection, let's see something. So if you take a prism is actually a triangular, a piece of, okay, it looks like this, okay, something like a tent actually, but it is so small it can be placed on your hand. So it is a small thing. It is completely made of glass, and it is called a prism. And when you should imagine that there is sunlight is there, so sunlight is coming, and we are taking a small ray of sunlight that is coming here, a beam of sunlight, and that when that beam of sunlight is sent to this, it can come through the other side. There is nothing obvious in that, okay. But for a prism, if there is a glass piece, assume that there is a glass piece, simple glass piece, okay, the light can come here and go through here, no problem at all, okay. So sunrise can pass through a transparent glass. Here this is also a transparent glass, but the problem is that it is made in such a way that you can see that it's special shape, that is something like a triangular, in that triangular shape you can see that, okay. So when the light comes and hit on one side, when it comes out on the other side, it won't be like a single light. So it will be consist of different colors. So here you can see that the light is coming, and when the light goes through that prism, it will split into different colors, okay. So that splitting of light, okay, splitting of not just a light, splitting of this light, and we call it as a white light, okay. So white light means, it doesn't mean that it is from a usual white LED or anything. It may also works, but white light means it is a composite light. That light itself consists of many colors. So that we can only know when we pass it through a prism. It will split into its components. So like if you send sunlight through this prism, it will comes like different WIBGR of colors: violet, indigo, blue, green, yellow, orange, red, okay, like this. So the same principle actually, and this splitting of white light into its constituent colors, what are the colors inside that splitting of light is called the dispersion, okay. It is called dispersion. So the best natural phenomenon of dispersion, as you know, that is a rainbow. So you have seen rainbow, and rainbow has almost all these colors. Anyway, you cannot see that this much perfect, but anyway, rainbow also has these colors. And how the rainbow happens? Is there any prism there? Somebody placing the prism there, and so that we can see the rainbow? No. Actually, what is happening there is the raindrops, okay, is tiny raindrops or the water drops in the air, okay, or in the atmosphere, acts like prism, okay. So when the light passes through those tiny water droplets, then it can reflect back, and this tiny water droplets will act like a prism, and it will split into colors. You can observe the same thing if you go near a waterfall or something on a sunny day, and when there is so many water, tiny water droplets are there in the air, something looks like a smoke or something like that. So at that time you may be able to observe a kind of a rainbow colors. So that is because of the dispersion. So dispersion is a common phenomenon that we can observe, and especially the rainbows are because of dispersion. So what is the purpose of a rainbow to do here, or what is the purpose of that for astronomy? Or okay, so let's see. what is its purpose. And also the same phenomenon or same coloring can also you can observe on a CD. So when you take a CD, on the writing side of the CD, you can see these colors of rain. So both the prism, okay, so this is the prism, and a simple CD has the ability to disperse the light into its constituent colors. So it is a property of both prism and CD. But in the case of CD, why it happens is because the CD is not a plain glass. If you zoom in into its microscopic level, you can see that there are tiny grooves are there. Okay, tiny tracks are there. So something like a running track on a ground or something like that. It's so big in the case of a real running track, but okay, running track, there are many tracks on the surface of a CD, and those tracks are causing this rainbow of colors, and it is called grating. Okay, so generally those things are called gratings. Okay, so grating and prism are two instruments in physics or in science. Okay, they are capable of splitting the light into its constituent colors. So any light can be split into its constituent colors. Now, what is the purpose of splitting these colors into, or the light into its constituent colors? So there the magic happens. Okay, let's see one by one. That is, let's take an incandescent bulb. This is an old bulb. Okay, you know that the filament bulb. I don't know whether you are familiar with that. Anyway, you have at least seen some pictures of this bulb, and I'm sending its light through a prism. Okay. Okay, so sending those light in through a prism, and the result will be something like this. You can see it consists of all the colors from the violet to that red. Okay, it can split into different colors. Let's see. So it is split into colors. So there is nothing amazing in that. Maybe it is actually amazing to see, but it is not the purpose of our. Okay, let's see. Now again we are taking another kind of thing, that is, here we are taking some, it is not sun. Okay, anyway this happens for sun as well, but here this is not sun, this is a hot gas. Okay, for example, we can take a tube full of gas, okay, some gas, and we can heat it up using some electricity. So that is a hot gas. So when it is at a very high temperature, the gas starts to glow. Okay, and then we send that glowing light, or the light from that glowing gas, again through the prism. Then the result is not just the continuous light that you have seen. We will see only some certain colors. Okay, you can see some certain colors, and that certain colors, or what should be the color there, depends on what was the gas. For example, if I have taken hydrogen inside that, or helium inside that, helium will give you a certain pattern of colors. And if I take sodium inside that, sodium vapor, okay, sodium is a metal, but I can take the vapor of sodium inside the then the sodium vapor will give you another pattern. Okay, so depending on what is the hot gas inside that tube, there will be different patterns here. Okay, so that is one thing you have to keep in mind. So the pattern what you are seeing on the right side depends on what is inside that glowing gas, or what is the glowing gas. Okay, so that is, I will give you another interesting example of that. You might have been seen this yellow light in the streets. Okay, so yellow, these street lights, you might be familiar in the cities and all. And why it is glowing yellow instead of some other color or something like the usual light? It's glowing in yellow because that bulb works on the principle of this hot gas. We are taking some gas inside a tube, and inside that tube the sodium vapor is filled, and then when it is heated up, it will give off light, glowing light. And that light, if you send through a prism, you can see that it consists of a pattern. You can see the pattern. Okay, So this is actually infrared, we cannot see, but beyond that, this is red, this is green, this is some blue, many different colors are there, but prominently you can see that two colors. You see, there are two colors so bright. So this bright yellow lines, they are called the name of that line is the D line of sodium. Okay, so this is called the D line of sodium. So that D line of sodium is giving that that special color to the street light, which is filled with the sodium vapor. And this kind of yellow lights are also called sodium, okay, sodium vapor lamps. Okay, so instead of the lamps. Okay, instead of this is, if you fill it with a neon, it will give you another color. If you fill it with another gas, it will give you another color. So it depends on what is inside. So now you might got a connection. So at least when you see an yellow street light, you can say that, yeah, that gas or that bulb itself consists of some sodium. Even without doing any experiments to verify whether it is sodium or not, you may guess that, yeah, it consists of sodium. Or next day onwards, if you go to a street and see a light like this, and which gives off yellow light, and it works on the principle of something inside that gas is there and that gas is glowing, then we can say that it is a sodium vapor lamp. But it does not apply for some other lights like the yellow like LEDs. Okay, it works on some other principle, so that is not the case. But here, in the case of lamp which glows with a hot gas inside that, for that we can at least assume or at least predict that it is sodium. Okay, so sodium has a special kind of line pattern, and based on that pattern we can say that whether the sodium is there or not. Okay, so that's about it. Now we are doing another experiment similar to that. So again, we know that if you send this first just the bulb light, the light coming from a simple bulb, so it is, this bulb is not a hot gas glowing bulb. It is actually a tungsten filament is heated and which is emitting light. So, and heated thing is, when it is giving off the light, it will give you a pattern like this. Now we are sending this light, okay, we are sending this light through a cold gas. Okay, we are taking a cube of cold gas. Okay, here this is a hot gas. Now we are sending a light through the cold gas and again sending it through a prism, and the final result you can see here. Okay, so what is the final result? Yeah, if it was something like this, only the bulb or that incandescent light, then it will give you a continuous light. But here, when we send it through a cold gas, there will be some absence of light. You see, some missing places are here. This is one missing light, this is one missing line, and missing light. So where this light goes, yeah, it is absorbed by that particular colors being absorbed by the cold gas. Okay, so the gas inside this container will absorb those specific colors. And again, which of those lines are being absorbed depends on what is inside this gas, inside this box. Okay, if it is hydrogen, it will give you a particular pattern. If it is helium, it will give you a particular pattern. If it is oxygen, it will give you another kind of pattern. So each element has its own pattern. Okay, just keep in mind, when you send light through a cold gas and analyze the light coming out of that gas, then depending on what is inside that box, each, okay, it will give you a pattern, and that pattern completely depends on what is inside that box. Okay, so that is the whole idea.
Hello.
Okay, now let's see the next one. Okay, so that is about it. And this is another example of some light that is coming from sunlight. So if you send the sunlight through the spectra or through the prism or through the grating, it will split into its constituent color, and there will be some lines like this. Okay, and we don't know what causes these lines. We can see only some lines are there, but we should be able to figure out what are they, or what kind of gas or elements caused these lines. So before going to inspect that, you can imagine it like this. So suppose there is a crime happened somewhere, and you are an investigation officer, and when you go there, first thing maybe we do is that we will analyze the scene and all, and the forensic department will come and analyze for maybe many things, but one of the main thing they investigate for the fingerprints. So they might get multiple fingerprints from there. Maybe that is maybe it includes the fingerprint of the culprit as well. Okay, that there are many fingerprints, and now from those fingerprints they can try to match with the suspects. So there are some suspects there, and what they do, they take the fingerprint of the suspects and compare with what is there in the crime scene. Okay, then if it is matched, then we can assume that they are the culprits. So in the similar way, when you look in the sun, you can see many patterns like this. Okay, so it might be some pattern, some of the lines may be due to hydrogen, maybe some due to calcium, or something due to helium. We don't know which are they, but once you know the actual fingerprint of hydrogen and helium, then we can compare it with the lines that is coming from the sun. So by comparing it, we can actually calculate. So I will give you another example. So here, this is an image of, or the diagram of different fingerprints of the gases. So helium will make a pattern like this. Okay, and oxygen will make it. So at one look, or at a single glance, you may think that all these are some lines, that's all. But wherever there is oxygen, that oxygen will make a pattern only like this. Two lines are this much distance, and after a certain distance, the next will be there, then this two close lines like this will be there. So this pattern will be the same for oxygen everywhere, where it is, whether it is on the in your chemistry lab, whether it is oxygen that we breathe, or whether it is the oxygen that is on the outer space, or wherever. Okay, wherever there is oxygen, the pattern will be the same. For the helium as well, that pattern is unique for helium. You cannot find the same pattern of helium for any other elements, not just this element. You know that there is periodic table full of elements. Okay, for no other elements will have this same pattern. Okay, so that is one advantage. That is why we call it as the fingerprint of elements, or we can call it as the, they are called the fingerprint of atoms or elements. So once you have the fingerprint, using those fingerprints, we can easily figure out what it is there. So that is the advantage. So neon has a fingerprint like this, argon has a fingerprint like this, xenon has a fingerprint like this. Now let's see, here you have an unknown. So what the scientists do, they will try to compare it with the standard. So how we know that helium, oxygen, neon, argon, xenon has this pattern? Yeah, scientists do experiment in lab, like the same experiment that I explained here. They will take helium here inside and find the pattern and record it and keep it somewhere. Then it is like a database of fingerprints of the suspects. So already all the investigation agencies, all the police has already a database of fingerprints of usual criminals. Okay, so like that, the scientist also has this database of the usual fingerprints, like the helium fingerprint is there, oxygen fingerprint is there, neon fingerprint is there. So we do have all the fingerprints. Now the idea is just compare it with something. Okay, now let's see. We got an unknown gas. Okay, so some light passed through an unknown gas. We don't know the name of that gas or anything. We got a and then we have to find out what this gas is. We don't know what this is, but we already have helium, oxygen here. Now we will try to compare it one by one. So let's see, can I match it with the helium? So it can be matched. So we can see, yeah, here two lines, but those two lines are so at a very high gap. No, it is not going to be. Now this is not. This may be, let's check. No, it is so close by. Then no, it is not. It's not. And finally, if you check it with the xenon, you can see all these lines are matching. Okay, see, So almost all the lines. But if you compare all the lines, all these lines will match. Okay, not just one or two. I have given only a sample of 4 lines, but all the pattern will match. Okay, so whenever there is an unknown gas and it has a unique fingerprint, we can compare it with any of the standard fingerprints we already know. Okay, then compare them and find out what is there. That is the way the scientists find out what is there. So what is the purpose in astronomy? Yeah, the purpose is in astronomy, suppose you have sun here, okay, and I have a telescope here. There are solar telescopes. No usual telescope can be used for a direct observation of the sun, but there are solar telescopes, and the light coming from that sun, okay, sunlight can be fed to a telescope, and again we transfer that light not just through the telescope. After the telescope, there will be an instrument which is capable of splitting that light into different colors, something like which is able to make a pattern like this, and that instrument is called spectrometer. The name spectrometer. Okay, so and what we get, we get a result like this, and this is called a spectrum. Okay, so the pattern what you are seeing like this is called a spectrum, and the spectrometer is the device that makes patterns like this, or it will analyze the light and we get what are the lines there and what are the colors there, etc. And from those result, that from that spectrum will consist of a lot of lines. So it will consist of whatever element. So sunlight is coming from its core and which is coming through its surface. Okay, then when it is passing through its atmosphere, the solar atmosphere, or through the sun, some of the light, some of the colors will be absorbed by whatever it is there on the sun. Some of the hydrogen is there on the sun, and some of the fingerprint that is corresponding to hydrogen will be absorbed. So there will be some lines corresponding to hydrogen. There will be something corresponding to helium. So there are many kind of that missing lines will be there. So now take the spectrum of sun and compare it with the hydrogen fingerprint, helium fingerprint, and finally find out what it is. Okay, so that is how it works. And once again, when I represent a picture like this, the spectrums are not this much visible in real case. It is not something this beautiful orange. So in reality, the spectrum looks like this. Okay, you can see this is a real spectrum of some target, and its location is given. This is a spectrum of a star, and there are some elements are already, so you can see neon is there. This is this dip. Okay, this dip means this is a dark line. So this is corresponding to helium, this is corresponding to oxygen, and this dip is also, and this is another again corresponding to hydrogen. So you can see that, especially you see this 1, 2, 3. So they are written as H alpha, H beta, H gamma, H delta. Just leave that name. Okay, but anyway, those corresponds to hydrogen. Okay, so from this graph, the scientists are able to figure out what are there. It is not that easy like what I have shown in this picture. This is for reference or to get an idea. So instead of showing initially, if I have shown this, you won't understand anything. But this is the real spectra, and using those real spectra, they are able to find out what is this there. Okay, so that is the idea of spectroscopy, and this is how scientists or astronomers are able to figure out what is there in a star, or maybe what is there in a planet without even going there. Okay, and there is many more interesting thing that we can find out. Suppose how much we say that this percentage of some 75% of a star is hydrogen, and another 25% is helium, something like that we see, or 10% is helium, and the remaining 90% is hydrogen. So that amount even can be figured out from this spectrum. So that needs some complicated physics and some other equations, and especially that comes from an Indian scientist called Meghnad Saha. Saha's ionization formula is there. Just leave that. Anyway, there are some complicated equations and science there, so that not just the element, but what is the fraction or how much it is there, that can also be, or what fraction is there, that can also be estimated from this colored light, or by just splitting those light into its constituent colors and finding those patterns, we are able to find out what is there, what is out there, what is the content or what is the chemical composition, and also we can get an inference about the quantity or the what fraction it is there. So that field of astronomy is called the spectroscopy. It is not just for astronomy. People are using it to find out what molecule is there, some chemical. Suppose in a chemistry lab, we find out some unknown element. Okay, usually we do some test in test tube and all, but it is not applicable for everything. So in that case also they take spectroscopy even in a chemistry lab or something like that. Then they get many results, and based on those results or from the spectral lines, they are able to find out what element is there, what molecule is there. So it's a vast field in science. Okay, so that's about it. So that is one thing that you can get, or one of the important thing that you can get from these colors. Now there is another thing that you can measure using these lines, or from the shift in this. Now before going to learn the other application of this, let's see why this is happening, or why there are unique lines for each element. So let's see why this is happening, and we will give you an example of Bohr model of atom. Okay, so I don't know whether you know about the atom model, but anyway, at least you know that an atom, okay, that is the basic constituent of anything. We can call it as an atom, and in that atom you can see that at the center there is something called a nucleus is there. That nucleus is consist of protons will be there and neutrons will be there. Okay, and around that protons and neutrons, electrons are orbiting. So this is one model of atom. Okay, now you can see that here it is written as 1, 2, 3, 4. These are all different shells. Okay, or we can imagine it is something like a certain place through which the electron can orbit. Okay, so electron can be here, can be here, can be here, can be here, and each of this step has different energies as well. Okay, so this is the lowest energy, this has bit more energy, this has more energy, more energy. So if an electron is in a higher energy, something like here, n is equal to 3, that means it has some higher energy. Then if it need to come to the lower energy state, that means n is equal to 2, it has to lose some energy, or it has to give off some energy. Okay, so what is that? It is something like some steps. Okay, so this is the lowest step, that means the lowest energy, in between energy, maximum energy, and an electron is standing here, so it has some high energies. Imagine that it has some 25 energy. I'm just giving you some numbers, that's all. And this track has an energy of say 17, and this track has some energy of some 12. Just assume, I'm just giving you some numbers just to understand the concept, that's all. So now the electron is in 25. Now if it wants to come to this level, okay, then it has to lose some energy. How much it has to lose? What is the difference here? Yeah, it is 8 energy it has to give off. Okay, once this electron gives off 8 energy, then it can come here. Now if it wants to come here to the lower one, then it has to lose again some 5 energy, then it can come here. Similarly, someone is sitting here, assume that in a cold gas, an electron is sitting here. If it wants to go to a higher level, it has to gain 5, then only it can go there. So that is why when that light is passed through a cold gas, okay, whatever is there, based on that, those electrons will get some energy from that light, and it will go to the higher level, and from here it will go to higher level. So based on that jumping, some energy will be taken, or that missing lines means these energies being absorbed by the electrons, so that it can jump from a lower energy to a higher energy. For that, or another way, we can say that those electrons have taken those particular energies from the light, and it jumped to a higher state. So that energy is used for jumping of electrons. So that is why those lines are there. And one more interesting thing, all the atom, if you take hydrogen to maybe to plutonium or uranium or whatever atoms are there, for each atom has different number of electrons are there, different charge are there, or the proton number is different, neutron number is different. So based on that, this step is also different. So hydrogen will have a certain type of steps and the helium will have a certain other type of steps. So the gap in the steps are different for different elements. So based on that, each element will have a unique pattern. So this is the reason why. Okay, so another example here I will show you. These are the patterns that is formed by hydrogen. So here you can see that either this is n is equal to 1. So when electrons can come from n is equal to 2, 3, 4, 5, 6, 7 to the n is equal to 1, that was a certain series of lines. They are called a Lyman series. And when n is equal to 3 comes to 2, 4 comes to 2, 5 comes to 2. Okay, here all of them are written in a form that it is coming to the lower level. Okay, it can happen in the opposite direction as well. Okay, you can go like this as well. That are also called the same name series. Okay, these are all the series of hydrogen. Just leave those names and all. This is not just for you. Okay, anyway, I have given an example. There are different series of lines based on what is the jumping happening. Okay, so when an electron is jumped from higher to lower, it will emit energy. When it goes from lower to upper, it will gives off energy. It is something like climbing a step. If you want to climb a step, you have to have some energy. Okay, if you want to jump down, there is no need of energy. You can simply jump, or that corresponding energy will be given off like sound or something like that. So that is the whole idea of this. And each element has its own configuration or its own different steps, and based on those steps they can jump. Okay, so that's now that is a reason. Now we can also do another interesting thing or another interesting measurement with sound. Okay, I don't know whether you are able to. Okay, so yeah, so there is an interesting phenomenon in physics called the Doppler effect. Okay, so before going to just read this Doppler effect and all, so assume that you are standing somewhere, okay, like this, and a car is passing by. Okay, this is a car and the car is passing by. So when the car moves towards in this direction, it is you can hear its sound, or maybe its horn can be heard. Okay, so it is continuously giving its sound. Okay, that means it is using its horn and you can hear its sound. So when it is coming towards you, so you are standing near here, and when it is, so it is going like this. So for the first half, that means when it is coming in this direction, it is actually approaching you. Okay, it is coming towards you, and after this point it is actually going away from you. So it is coming towards you. From here onwards it is going away from you. So when it is coming towards you, you will hear the sound as a high pitched sound. Okay, I will explain what is high pitch and low pitch, and when it is going away from you, you will hear it as a low pitch. Okay, so just for a moment I will stop sharing, and I don't know whether you are able to hear this. Not possible, I think. Okay, just leave it. I will share the screen. Okay, I hope you know what is a piano is. Okay, I couldn't share this sound. I don't know why it is not transmitting the sound anyway. Let's share an option. Okay, I hope now you can hear. Can you hear this? If you can hear, just put it in the chat. Can you hear when I click here? Yes, okay, fine. So high pitch and low pitch means, okay, so that is usual term that we use in terms of sound or music. We say that high pitch and low pitch. So you can hear just not this sound. a sweet sound, or we say that it's a sharp sound. Okay, and when you go to the left of the keyboard, you will get more bass sound. Okay, so this is something like a sweet sound, and this is something like a more bass sound, and this difference is called the pitch. So this is a high pitch sound and this is a low pitch sound. Okay, but this pitch means that is the usual term or the word that we use in case of music or sound. But in physics, what is actually happening? So here this sound, we say that this is a high frequency sound. That is the term that is used for pitch. Instead of pitch, we say that this is a high frequency sound and this is a low frequency sound. Okay, so now when a car which has a certain frequency, that is its horn's frequency is a certain frequency, usually when it is stationary you can hear its horn, it's fine, but when it is coming towards you, you will hear it as, suppose that this is the sound of the car when it is stationary. Stationary means there is no motion between you and the car is stopped there, it is stationary and you are also standing still, so the gap between you and the car is not changing at all, and now you are listening to its horn. Okay, it's suppose it is like this. Now the car starts and coming towards you, it is again playing this music or maybe the sound. Then when it is coming towards you, you will hear it something more high frequency or high pitch. And at the same time, this is the original one, when it is going back or going away from you, you will hear the sound like this. Okay, so this change in sound or the change in pitch of something is called the Doppler effect, and it happens because of the movement of something. So when something is moving towards you or away from you, that can cause a shift in sound, and that shift in sound is called, that phenomenon of shifting sound is called the Doppler effect in sound. Okay, so whenever you hear a siren or something like that from a moving car or something, you can notice this. It is not about the loudness of the loudness is also changing, but it is not about the loudness, it is about that sharpness of the sound, something we call it as the pitch, or we can, in terms of science, we can say it as the frequency. Okay, so that's, so now when a source is moving towards you, you get a higher frequency, and when it is moving away from you, you hear a lower frequency. Okay, now what is the purpose of this? Yeah, this happens not just for sound, it happens for light as well. Okay, so imagine that there is a source of light, and when it is coming towards you, its light will shift to a higher frequency, and when it is going away from you, it will shift to a lower frequency. So what about this frequency? Okay, so frequency means, so you can imagine a wave like this. Okay, suppose this is a wave and this wave is moving as well. Okay, so now you are standing here and counting how many crust or this top portion is passing through you. So you will count it as 1, 2, 3, 4, like that. And if it is a fast moving wave or it is something like a high frequency wave, that means we can see like this. If this wave is passing to you through you, then you will count it as 1, 2, 3, 4, 5, 6, like that. So the number of waves passing through you changes. So in 1 second, in the previous case, you got one wave or one top in 1 second, like this, 1, 2, 3, like that. Now for this wave, when it is passing near you, you will count it as 1, 2, 3, 4. That means at least 3 in a second. Okay, so that is a high frequency wave. So in the case of light, high frequency light means, so the lights that are near the blue or the violet or indigo, they are all the high frequency, and one is near the red is the low frequency. So now what is the purpose of this Doppler effect in astronomy? Okay, anyway, there is no sound is coming from space to here, so we have to analyze the light again. So in the case of light, suppose there is an object. Okay, object means suppose you are observing a star, okay, or something like that, and you are observing it from ground, and you got its line like this, a pattern like this. So this pattern is the spectrum that we discussed earlier. Okay, now in earlier case we used this Yeah, in the earlier case, we used this for finding what are the elements there. Now we are using it for some other purpose. Okay, so in the case of sound, that frequency shift is happening because of the that change in pitch is happening because of the car is whether it is coming towards you or away from you, and also it depends on the speed. Similarly, now there is a star, you are observing this star through a telescope and sending its light through that instrument called a spectrometer, and you are getting a pattern like this. But today we are not going to find out what is there inside that star. Just leave that for now, we already know, so there is no point. So now there is no movement, the star is stationary. Now suppose for some reason, okay, just imagine, okay, this for no reason, okay, this star is starts to moving away from us. Okay, so the person is standing here and the star is starting to move in this direction. Okay, so you can imagine something like that. Then also again you are taking that spectrum, and the spectral pattern, you can see the same pattern is here. But what happened? All the patterns are here, but all the patterns or those lines have shifted towards the right. See, it was here and it's shift towards the right. So the all the pattern should have been here. Okay, but all the pattern has shifted to the right when it is moving away. And shifted to the right means which side? This is the red side and this is the blue side. Okay, so all the light, all those lines have been shifted to the red side, and that shift is called the red shift. Okay, so when an object, okay, is moving away from us, the light coming from it will be shifted towards the red side. Okay, or we can say that longer wavelength side or low frequency side. So just leave that frequency and wavelength thing that we will learn in higher classes, but before that you can see that it will be shifted towards the red side. Okay, now what if it is coming towards you? Okay, there should be some other change. Okay, let's see that. Now again we are taking, suppose that star is coming towards you. Okay, then again we get a line like this. It's for fine, no problem. And if you compare it, when the object is moving towards you, yeah, all the line have been shifted towards the left, that means to the blue side. So shifting towards the blue side, we call it as the blue shift. So this same shift is applicable for every point. Here you can see that same gap. Here also the shift is constant for every line, not just for every line. That here this is for this is here. Okay, so all the shift are constant, and that is called a blue shift. Okay, now we got two types of shift. One is called a red shift and other is called blue shift. So when you analyze the light from a star, if the spectrum is shifted to the red side, we can say that it is moving away from us. And if the spectrum is shifted towards the blue side, then we can say that it is moving away from us. Okay, sorry, it is coming towards you. So similarly, when Edwin Hubble, a scientist, okay, you will learn in detail in the last class on Friday session, don't worry. Anyway, Edwin Hubble, when he observed galaxies and he analyzed the light coming from this from those galaxies through a spectrometer, and he found out that almost all the galaxies, the spectral lines are shifted towards the red side. What is the meaning? Yeah, almost all the galaxies has a red shift. That means almost all the galaxies are moving away from us. Okay, so that is how he made the conclusion that the universe is expanding. And some of the nearby stars, for the nearby stars, nearby galaxies, when he, especially Andromeda galaxy, when he observed, its line is, or its spectral line is actually shifted towards the blue. That means the Andromeda is coming towards us, and that's true in some billion, maybe more than some million, billion or trillion years, the Andromeda galaxy will collide with our galaxy. It is coming towards us. Okay, so this kind of estimation can be made using the spectral lines. So whether it is either red shift or blue shift, we can make an idea that whether it is coming towards you or moving away from you. But not only that, okay, it is not just a knowledge of whether it is coming towards you or away from you, but you can even measure the velocity. How much? Based on how much it is shifted, okay? Whether it is shifted like this, or it is a small shift or a big shift, based on that we can actually calculate at what speed it is moving away or moving towards. Okay, so that is also, so this is just the equation, just leave that equation. I'm not going to explain this anything here because it is beyond your level. Anyway, just understand that you can calculate what is called, from this shift we can calculate the velocity or the speed at which it is moving. So it is not just the knowledge of whether it is moving away or towards, but also we can infer what is the speed at which. Okay, so Doppler effect has two purpose. Okay, one is whether it is, we can find out whether it is moving away from you or coming towards you, or also you can measure the speed at which it is moving. Okay, so that is the advantage of Doppler effect. Okay, so or that is how astronomers use Doppler effect in astronomy. Okay, so Doppler effect usually initially it found for sound, and it is also applicable for light. So Doppler effect is a it's a phenomenon which is applicable to both light and sound. Okay, and similar thing is also used in some you might be seen that when you go through highway and all, speed controlled by radars, something like that being written on. Okay, so speed controlling radar will be there. So those radars will send some light, some radio waves towards your car, and when it is reflecting back, there will be some Doppler effect will be there, and based on that they are able to measure the speed of your car. So they are called Doppler radars, and using those Doppler radar they are able to find the speed, and they can decide whether to find it or not. Okay, so that is another application, another daily life application of Doppler effect. And this is another effect. So using this we can actually calculate the many things, something like this. Maybe this method is also used to find other planets. Okay, okay, so that is how it works. Okay, so these are the equations I'm giving you. Okay. Okay, so that is about it. Now, yeah, this was a small topic, so we completed it even before. So I will take the questions from the chat first. Okay, then I will unmute you. Okay, so there are some questions. So the last questions that I have a doubt. Okay, so I didn't get how the speed and velocity of an object can be calculated. So speed and velocity is first of all two different things. But as a junior student, just leave it as speed. Okay, just take it as both are almost the same, but in physics they are actually different. Okay, so the speed and speed can be calculated from how much shift is there. So we can calculate how much it is shifted, and from that shift we are able to calculate the speed. Okay, I am just giving you that directly. I am sure that I haven't taught you that, because that includes some equations like this. Okay, here you can see it consists of a v, that means the velocity. From this equation we can calculate velocity. So just leave that, because then you have to learn what is lambda, etc. So that is not, and this derivation of these equations are not at your level. Okay, so that is why we are saying that. Okay, so we take some of the questions from the chat, not every, at least I will take some 3 to 4 questions till 6:30, then I will unmute you one by one. Okay, so can you explain the main sequence? I haven't explained here, don't worry about that, because it is beyond your level. That is why I am not explaining main sequence, so just leave it. Okay, how the gases make such fingerprints? So they are making such fingerprints because each atom has its own unique electron levels. So electrons are filled in different levels, and that level is unique for each atom. Hydrogen does have a different pattern, the helium has a different pattern. So based on that levels, it differs. Okay, what is the fingerprint of calcium? You can search Google for the spectrum of calcium, and it will give you an answer. So just simply go and type spectrum of calcium. So this is the calcium. Yeah, you can see it's almost all the element you can get it in the Wikipedia. So this is the spectrum of calcium. Okay, now can this element of a star be found out of the star is too far to observe or capture any light of the? Yeah, if there is a star and we can find, how will you say that there is a star without even seeing the light? So if there is a star, we should receive some light, then only we know that there is light is coming from that, then only we know that the star is there. So if we are receiving the light, then we can do it for the spectroscopy, or we can pass it through that instrument. So that is not a problem. Okay. So for energy, to measure the unit of what is the unit to measure energy of an electron? To measure the energy of an electron, we can even use the usual unit called the joule, but usually where we use is called the electron volt. Okay, electron volt is usually used. So in the case of Bohr atom model, what I was trying to explain, for each type of element has electrons are actually distributed around the nucleus, and that distribution of electrons are in certain channels or certain paths. They are called what is to say, they are called shell, or we can call it as a path, and that path depends on what element is there. So based on that, there will be energy. Okay, so that based on that, the electron can jump between those levels. Okay, so that is what I was trying to explain in that. Okay, so there is electron nucleus as the center, and there are different paths for electrons. So electron can jump between this path, and that jumping will cause this spectra or that fingerprint. I have a doubt that redshift happens due to the expansion of the universe. Okay, the redshift can even happen due to the expansion of the universe as well. So there are two kind of expansion. One is the Doppler redshift, and the expansion redshift is there, cosmological redshift, that you will learn in the last session, or for the cosmology session, you will at least know that what is there. There is no sound in space. Yeah, that is, there is no sound in space. The Doppler effect is initially found by the scientists, or discovered, invented for or discovered for sound, but the same thing applies to the light as well. Light also shows Doppler effect, so there is no problem. We How can we heat a gas? So we can heat a gas so simply. You can take it inside a metal, just imagine a metal container, sealed container, then heat it. The gas will get heat. Okay, no problem. So when you lit up a candle, the nearby gases are actually heating up. So there is no problem in heating up the gas. Okay, now I will take questions directly. You can actually do the, you can hand raise. Okay. I will stop sharing for now. So I will call one by one. Okay. So Rajani Vishakarma. Okay, I don't know whether okay. You can unmute and ask. Okay, Rajani.
Yes, sir.
Yeah. What's your doubt?
Sir, so my doubt is, sir, what is a, sir, I can't understand, sir, this Bohr model of an atom.
Okay. So just take it. I will explain.
Okay, sir.
Okay, so the Bohr model of atoms, actually it is a bit difficult in the sense that you haven't learned it in your school classes, I think. So when you go to your higher class, especially in your higher class, you will learn it in detail. Okay, I have just given an idea what it is. So if you take an, suppose you have a sugar cube, if you split it into two, it will become two, and again take the one other piece and cut it into half, again. If you go on, and finally you will reach something called the molecule of that sugar. Okay, and if you split it again, all the elements or whatever that you are seeing in our universe or around you is actually made up of something called atoms. That is the basic building block. It is something like the brick. Okay, to make a house or something, we need something called a brick or something. That is a fundamental block. Like that, for things to be made or materials to be made, it is actually made with the small things called atoms. Okay, and those atoms, if you look inside an atom, you can see that its center consists of something called a positively charged protons are there, some neutrally charged neutrons are there, and around which there is some other kind of particles called electrons are orbiting. It looks like something like of a solar system. Okay, so it has its own path, and through this certain path, okay, electrons are orbiting. You can see electrons are actually revolving around the nucleus. Okay, so this is the idea of atom. Okay, so this is how an atom looks according to Bohr. That is the Bohr atom model, BOR. Okay, so electrons are actually moving in this certain path, and the electrons can jump in between. Okay, and due to that jumping, there will be a unique fingerprint for every atom. So even though you couldn't understand anything about this Bohr atom model, or this is something, this is usually a high school topic, but just for the completeness, I have just mentioned that. So leave it. You will understand. You will when you go to the higher classes or a senior level, then you will learn it in depth. Okay, at least it should take some 1 month to learn all these things. So when I am talking that in a 1 hour lecture, it is not that easy to grasp. That is understandable. So don't worry about that. Okay, just keep this in mind, and when you go to the higher class, you will learn it. Okay, don't worry. And especially about the exam, don't worry. There won't be anything beyond your level, in the sense that those questions, something like the Bohr atom model and how this shifting happens, there won't be questions like that. Okay. So let's see. Yeah. Now, Ahana.
Yes, so I wanted to ask first, what is spectroscopy? And I did not understand why there were dark lines in between.
Okay. Spectroscopy means actually analyzing the light. Okay, it is actually analyzing the light through an instrument called a prism. Okay, or
Yes,
some
sir.
tool called a prism. So prism has the effect of splitting those lights into its constituent colors, or what is inside that light. Okay, is it consist of only a single color, or whether it is consist of some different colors, which can be analyzed using a prism, or and that method of, or that system of converting this into its constituent color and all, this is called the spectroscopy. That branch of science is called the spectroscopy, and the instrument which does is that called a spectroscope or spectrometer. Okay, usually
Yes, sir.
spectrometer. Okay, now why this? So when we analyze the light that is coming from a hot gas, or light that is passing through a cold gas. Okay, suppose that some light is passing through a cold gas, and when that light is analyzed, it is not just a continuous light, but there are some missing dark lines. Okay, something like this, and those missing dark lines are unique for each element. If the light is passing through helium, the pattern will be like this, and if it is passing through oxygen, it is like this. So that uniqueness of lines are so important for each element, or that is unique for an atom. So once it is unique, it is easy to identify it using that pattern. And the reason behind why it is happening, why it has this dark lines, that is what I mentioned. The electrons are there inside atom, they are making jump in between levels, and due to that jumping, it will absorb some energy from the light, and those are coming as the missing lines. Okay, you may and may not understand the why part. Okay, that is why this jumping is happening, so that you can leave at least, but you should notice that each element has a certain pattern, or certain missing lines will be there, and that is unique for those atoms, and from that uniqueness, something like a fingerprint, we can easily find out what is that. Okay.
But sir, dispersion of light generally happens with a prism, but how can elements like these gases To do dispersion of light.
Elements are not doing the dispersion. The light coming from the you have seen this, okay? Let's see here. Here, the dispersion is again doing by the prism. Okay, the light is coming
Yes,
from
sir.
here, and some light will be absorbed by. So here also, so suppose this is this light looks like white. When it is coming through this cold gas and coming in the other side, again it will looks like white. We won't notice any difference in that. Then we send it through a prism, then only we can see whether there is missing or not. Okay, once there is no such an instrument like the prism, we cannot see any constituent colors or what is inside that. Okay, so that splitting happens, then only we can see that what is there. Okay, especially for this kind of, this looks like a white light, and when it is plastic, so if you are looking here, what is the light? Yeah, you can see some light here. Here also you can see some light. You won't notice anything, but the spectroscope is the thing that is making it dispersed. Okay, that is the one doing the dispersion. Not this gas is not doing the dispersion. The gas is doing only one thing, it is absorbing some light. Okay, and which become visible only when it is passed through the prism. Okay, now Ayan Singh, you can ask.
Yes, sir.
Yeah,
Sir, does the celestial body gives out the fingerprint?
the celestial body doesn't have any fingerprint, but what is inside that celestial body, that means what is the constituent of that uh, celestial body, do have that unique fingerprint. So if suppose some celestial body consists of hydrogen, that hydrogen has the unique fingerprint. Whether it is on a star, whether it is on some nebula, whether it is on some planet, wherever the hydrogen is there, the fingerprint is same. Okay, so celestial body doesn't have a fingerprint. The constituent elements in that, or the material inside that, has that fingerprint.
Yes, sir. And does the sun is going through the stage of a red shift of or a blue shift?
The sun is not going through any red shift or blue shift because we are at almost the same distance. This is not going away from us. If you want to observe red shift or blue shift, it has to go away from us or it has to come towards you. So in the case of sun, usually that kind of red shift is not happening.
Okay. Thank you, sir.
Yeah. Now Arush can ask. Okay. Yes, Arush. Arush, you can ask. I cannot hear you. Hello. I think some problem. Okay, you can raise the hand later. I will unmute you later. I cannot hear you. Okay, Chakri. Okay, Chakri. I don't know how to pronounce that. Okay, you can ask.
What will make the electrons jump to another shells?
So when it gets energy, okay, when there is light is falling on that atom or that gas, okay, so the electrons can get energy. So and then it can jump. So what makes it jump is the energy from the electrons. Okay, sorry, and not energy from the electrons. The energy from the light is making it jump from one step to the higher step. Okay, so that energy is causing the jump. Okay, now Vaishnavi Maurya, you can ask.
Hello, good evening, sir.
Good evening.
Sir, I didn't understand the Bohr model of an atom, the zinc one.
Okay, you just leave that, don't worry about that. Okay, that Bohr model of atom is not for kids like you. Okay, anyway, I just included that in the slide, so don't worry about that. That is about how an atom, or basically what is the basic constituent of a material looks like. So just leave. there are electrons which makes jumps, and those jumping is causing these lines. Just keep that in. So don't worry about it.
And then understand the second pic of the slide you have shown.
Which one?
So the second pic, the sun and the prisma and the its answer.
Yeah. Okay. What you couldn't understand? Which one?
Sir, this sun and the prism one.
This is not the sun again. I have mentioned that in the slide. This is not sun. This is some hot gas. Okay. So a globe full of hot gas is taken, and when it is sent through, when it is a hot gas, it will give you some certain lines like this. Okay. So when the light is passed through a cold gas, it will give you some missing lines. Okay. That is two kind of spectrum.
Okay, sir. Thank you, sir.
Okay. So now JHILM Jailam Chatterjee, I think. Okay. You can ask.
Sir, I couldn't understand how a prism splits the light.
Yeah, okay. So the prism is has the ability to split the light because, okay, so its special shape is there. So each light, when light comes inside this, it can split into different, because the light that is encountering here will go through different distances, or in other word, the constituent light has different velocity speed. So the red has a certain speed, the blue has a certain speed, and the green has a certain speed, or each light inside this medium has a certain speed when it's moving. So based on that, it will change its path. Okay, so inside that medium, but in air there is no problem. So when it is inside this medium, and because of the special shape, the light has to travel, each light will travel different angle. It will disperse to different angle because of the difference in its speed. Okay, so that is why it is coming at out different. Okay. So the red will bend only this much, and at the same time the other one, that is what is called the blue, will shift more, so that it will come here. So that the difference in speed is what is causing this splitting. So different colors has different speed, and that is causing this stage. Okay.
Thank you, sir.
Okay, thank you. Now Vihan Rajput, you can ask. Vihan.
Sir,
Yeah.
I had a doubt that does the Doppler effect help to measuring distances to planets or stars? For example, if a star has the redshift, so will the redshift of the star help in measuring the distance to it?
No. Redshift doesn't help us to measure the distance. It only help us to measure whether it is coming towards you or moving away from you. Also the speed at which it is moving. Okay, so it can measure the speed and whether it is coming towards you or away from you. It cannot measure the distance. So for distance measurement, we have to use any of the methods that we discussed earlier. Okay, in yesterday's class. Okay. Now, Dia MP, you can ask.
The trackings on the CD are called gratings, or just all kinds of materials which let the light to split are called
No. So you can use two types of thing to split light. Okay, so one is prism, and the other one is called a grating. So grating means it is actually a piece of glass, and there will be so much lines. That means in 1 centimeter there will be hundreds of lines scored in that. So it is something so close by lines. It is not like this, we cannot even see that. If you look through a microscope or something, then we can see that there are tiny lines. So this tiny lines means one of the, where there is line, it is opaque, and where there is no line, that is transparent. So if you make anything, if you make something, a glass like this, then it can also split light. Okay, and that instrument is called the grating. Okay, now CD is actually not a grating, but in the case of a CD, the CD has some kind of this line on its surface. That is why it is actually giving those rainbow of colors. Okay, so real grating doesn't look like that. That is something that, okay. So you can see, I don't know, is there any real picture? So this is some example at least you can see here. So that is also split the light. That if you get something semi, they don't have a real picture. Yeah, just leave it anyway. So that is some kind of a glass which has a lot of lines in that, which is able to split the light, and that kind of things are called grating. The CD also has lines like that. That is why it can split the light. Okay, CD is an example of grating. That's all. Okay, surface of, or the reason behind the light that is coming, the rainbow of colors that is coming from the CD is because of the principle of grating. Okay. Now, Arnav, we can ask.
Hello, sir.
Yeah.
Actually, I was like I didn't join yesterday's class, so I just wanted to ask where can I get the recordings?
I think you will get the recording by mail or something. You can actually ask the Edumitra team. Okay. So someone who send the link, class link and all, you can ask them directly. Okay.
Okay, and one more thing.
Yeah.
Like Edimitra sent me a message. So when is the exam exactly? Because I was told it was on 29th, but then it's like 14th and
That's
15th.
so things like this you can ask the Edumitra team, because I am the faculty there, so I am only dealing the academic things. Okay.
Okay, sir.
I'm
And
sorry. Okay.
actual academic question I just wanted to ask about the atoms.
Hmm.
So can you tell like how the energy is shifted?
Which that jumping of electrons.
Yeah.
That is just if an electron want to go to a step with the higher energy, it has to get some energy from light, and if it wants to come down to a lower energy, it has to lose some energy. Okay, so simple
And
idea.
how will it lose energy?
When it is so if it wants to go to a higher stage or higher energy level, it can get energy from the light, that you know already, I think. And if it wants
Yes.
to come down, it has to give off that energy, and that energy will be sent as light. Okay, so when it is coming down as well, when it is coming down, it will give light, and when it is going up, it will take light.
So like elements like luminous elements like I guess uranium. No, yeah. So sorry.
Any element, any element.
Yeah, radium is luminous in nature because of it emitting light, right?
That emission of light is something else. Okay, that has to do something with the radioactivity and all. It is not because of the electron jump.
Okay.
Okay.
So like once the electron jumps, it emit light. Once they jump down, they emit light, right?
Yeah, and that jumping of electron from a higher level to lower level only happens for a hot gas. Okay, usually, especially invisible. So, for example, if you take some sodium vapor and heat it up, then the electrons can jump from a higher stage to a lower stage.
So that will because of which the light is being emitted.
Yeah, that is one reason why the light
Yeah.
is. So that is one way of making light. Okay, to make light there are many different ways. This is one way. The electron jumping can cause emitting light.
Okay.
Yeah.
So and if
Yes.
yeah, and if the doubts are done, can I leave if my doubt is cleared?
Yeah, if you want to hear the others doubt, then you can stay, otherwise you can leave.
Okay, sir.
So now Shaurya David. Okay. Shaurya David, you can ask. I don't know I'm pronouncing the name correctly or not. Not David, Dravid. Oh, sorry. Shaurya Dravid. Hello? You're not unmuting. Okay, then.
Yes, sir.
Yeah,
My
yeah.
my mic was not unmuting.
Okay, fine.
Yes, sir. So I had this question earlier that how are type 1A supernovae used in distance measurement?
Okay, that's from yesterday's topic. So type 1A supernova has a speciality that every supernova has a brightness. Okay, so that brightness vary over time as well. Okay, so that brightness has a peak moment. Okay, so
Yes.
the brightness will go something like this, or maybe you can imagine. Okay, so when the brightness is at its peak, okay, all the type 1 supernova, whether it is happening in one galaxy or the other, wherever it is there, okay, for all the type 1a supernova, when its brightness is at peak, okay, its energy emission is the same. Okay, whether it is in the galaxy Andromeda, whether it is in the galaxy Cigar galaxy, or wherever it is, no problem. If it is a type 1a supernova, then when it is at its peak brightness, the energy emitted by it is the same. Okay, so we know the actual energy from that, then with using that we can estimate the distance. So that is the speciality of type 1a supernova. No other supernova can be used like this. Okay.
Okay, sir.
Now Ahana again, or I called you, I don't remember. Okay. Manaswi, you can ask.
So, my mic wasn't unmuting. I just wanted to ask one more question. So, I don't
Sure.
understand the difference between redshift and a blue shift. Like, how do they help us measure distances?
They are not helping us to, I haven't said that they are helping to measure the distances. So the red shift and blue shift means when there is some light is coming from a celestial source, okay, like this, okay, if that object is moving away from you, this is when it is at rest we get some certain lines, okay, and when it is moving away those lines will be shifted towards the red side. So this is the actual place at which we are expecting those lines. Now it is shifted towards the right, or means to the red side. That is called the red shift. At the same time, if it is coming towards us, instead of shifting it to the red side, it will shift towards the blue side. And that change in actual position of the spectral lines are called a shift. And whether if it is shift towards the red side, it is called red shift. If it is towards the blue side, it is called the blue shift. And using this blue shift and red shift, if it is a red shift, we can say that the object is moving away from us. If it is blue shift, we can say that it is moving towards us. And from this, we cannot measure the distance to an object. We can measure the speed at which it is moving away or towards us. Okay.
And sir, what are the Lyman, Balmer, and Paschen series?
So they are all the names of the hydrogen. For example, hydrogen also has this fingerprints. Okay, so those lines. So hydrogen has these lines, and those lines are categorized into different series, and they are named as Lyman, Balmer, like that. Okay, so they are the names of the hydrogen lines.
And so sounds cannot travel through vacuum. So you said that light Doppler effect applies on light and radio waves as well. So how does it apply?
Yeah, it applies to radio waves and sound, light. Okay, no problem.
So I was
It doesn't
asking,
apply.
how does it apply? I mean, light does not have any sound, like you said, the car horn.
Yeah,
So in
that
that,
it applies not just, yeah, I got your question. So light doesn't have any sound, but both the light and the sound, they have a common property. What is that? They are both are waves. Okay, they're waves. Light is a kind of a wave and the sound is a kind of wave. So both these waves exhibits Doppler effect. Okay, so it is not, light is exhibiting Doppler effect not because of it has any relation with the light, sorry, it has any relation with the sound. It is showing Doppler effect because light is a wave. Sound is also a wave.
Yes, sir.
Yeah, okay. So now, Manasvi, you can ask.
Sir, can you explain in short Doppler effect?
Which one?
Doppler effect.
Yeah, Doppler effect. So Doppler
And
effect.
sir, can you show the screen too?
Yeah, I hope you can see the screen. Yeah.
Yes, thank you, sir.
Yeah. Okay. So here the Doppler effect means that is basically the shifting of pitch. So Doppler effect applies to both sound and light. In the case of sound, that effect appears as the change in pitch of the sound. So whether it is a sharp, sweet sound or whether it is a bass sound, that depends on whether it is moving towards us or away from us. Okay, so when a car with a horn, it is coming towards you, we hear the sound as it is being at a higher pitch, and when it is moving away from us, we feel it as a lower pitch. That is the Doppler effect in sound. Now the Doppler effect, the same thing applies to the light as well, because light is also a wave, and in case of light, what happens is that when the object, light emitting object is traveling away from us, then those lines, so those dark lines will be shifted towards the red side, and when that object is moving towards us, those lines will be shifted towards the blue side. So that is why we have two kind of shift. So Doppler effect in sound, we say that there will be a shift in pitch because of the movement of the sound source, and here in the case of light, we say that there is a change in color, or maybe there is blue shift and red shift because of the movement of object. Okay, so in case of sound, there is a change in pitch, and here in case of light, there is a change in color. Okay, now I hope Chakri, once again you have a doubt, I think you can ask. CHAKRI, you can ask if you have. Yeah.
Sir, like in the hot gases, are there any specific gas, or it can be any gas?
It can be any gas. Any gas, if it is a solid material like the sodium or something like that, then we can take it, we can make it heated and we can take the vapor of that. Okay.
Okay.
So it can be anything. Now Rajani Vishakarma, you can ask.
Yes, sir.
Okay. Yeah.
Sir,
Yes.
sir, so my doubt is, sir, can you please explain the standard candles?
Standard candles. So standard candles are the sources of astronomical sources, like it's there, and for which we know the actual energy emitted by that. Okay, so objects, astronomical object for which we know the real energy, what is the total energy emitted by that. So those objects are called the standard candles, and one of it is the Cepheid variables, and other one is the type 1a supernova. Okay. Now I think the time is up. Now it is already 7:01, so we will see you tomorrow, and we will engage with more doubts and engage with the remaining topics tomorrow. Okay, see you all. Thank you for being with me. See you.